Hi, my name is Antti Komulainen. I'm a specialist on data analytics at Raute, and in this presentation, we'll take a closer look on data-driven LVL production. So what are the must-have things and why? Just briefly, in the beginning, few words why data from your production process is important. Production data can be seen as quite low-level data on the whole IT architecture of an LVL mill. What's happening within some minutes or seconds may not sound super important to track, but in the long run, that data builds up a coherent picture what's happening in production. What are the must-have things for every LVL mill? Simply put, it's about production output volumes, it's about uptime. Combine those two, you get your production capacity. It's about raw material input, put that together with output and you get the recovery. It's important to have these things process step by process step and as well mill-wide. You'll cut many delays or misunderstandings in production planning and maintenance execution when you have solid ground to build on with the production and process data collection. In practice, when talking about these things, you rely on numbers from management information system type of solution. Raute's solution in this area is called MillSIGHTS. We have delivered MillSIGHTS data collection system to several hundred production lines over the years. With this data at your hands, the daily operations at mill regarding production and maintenance as well as quality control becomes easier than ever before. With Raute MillSIGHTS, there is very wide range of data collection points throughout the process. The beginning of LVL process is very much similar to plywood production, and so is the data collection. However, LVL process is not forgotten and there is the special LVL specific things we can offer. Not the devil, but the bevel is in the details. Up next, we are going to look at a very concrete example what you can and what you probably want to measure. There are three ways of jointing veneer sheets in LVL product. With simple overlap and butt jointing, the veneer edge is straight. With scarf jointing, we make a bevel to the edges of the sheet. There are clear visual looks and strength-related benefits when doing the scarfing. When it comes to data collection, let's focus for a moment on the scarf saw and the bevel. Since in LVL, very big share of the sheets are ran through scarfing, you definitely want to keep your scarf saw in a good shape. Raute scarf saw has always a pair of sensors scanning the bevel quality right after the sawing. If for some reason there is too big piece of wood missing in the bevel, the sheet gets automatically rejected so that no faulty sheets cause capacity loss at layup or worse, get into the final product. So far, all this is part of the standard line controls and nothing to do with the data collection really. When we look at the bevel, of course there's always some missing pieces depending on the sheet grade, and some of those imperfections are allowed in the final product. But if the share of missing pieces starts to grow, it can be an indicator, for example, that the saw blades are damaged. And now we come to the data part. Let's say our total width of missing wood in the bevel we allow per sheet is 100 millimeters. In other words, we allow altogether 100 millimeter hole in the bevel. Let's take a practical example. Last week, reject rate at scarf saw was 0.5%. This week, it's gone up to 2%. What might have happened? When you see the reject rate grow, it's already too late. Instead of being proactive, you are now reacting on things, and that's when it tends to become tricky and expensive. With the proper data collection, we can detect if there's piece missing in the bevel, but what is also done is we measure the actual width of the holes. The total width of holes in bevel may be growing within the acceptable limit for a long time before it exceeds the limit being rejected. So, in addition to the standard sheet reject function in the line controls with MillSIGHTS, you can follow this up. And it's very natural to set up an alarm for yourself for these kind of events. Back to the example case. So, what could have been done? We can follow up the measured hole per sheet and look at the left-hand side and right-hand side separately, here in purple and blue. Now, when we look at last week again, we can see that the left and right side are similar, where most of the scarfed edges have less than 50 millimeter wood missing. What we didn't notice earlier, that the things started to change already during weekend. The purple distribution starts to slip towards right. It's not yet affecting much the total reject rate, but we can see that within the 100 mm limit, there is a clear difference between the blue and purple distribution. Somewhere during this week, things became obvious also when looking at the total reject number of 2%. Now, when we look at the left-hand side versus right-hand side, here the change is dramatic. What could have been done on Monday the latest is to make sure it's not been the forklift that has damaged veneer edges in stacks. If not, then start keeping a close eye on the trend on the left-hand side to see if you may operate until the next maintenance day or if you should go and check the saw adjustments right away. The scarf jointing bevel may not sound like a big deal, but when you want to have as high strength properties as possible throughout the whole final product, this is also an area not to forget. At least it's a thing that you don't want to have extra worries with. And with the data collection and the digital tools, you can keep it in best possible shape. Thousands of sheets per day create great statistics. I'm not a specialist on machine learning or AI, but quite often you hear people saying machine learning is just statistics. And that's the beauty of industrial Internet of Things and the data collection when you get huge amounts of data quite quickly to analyze and build your own statistical models. The data itself is often very simple, as just seen. To begin with, this type of approach on scarf saw, you can achieve better timing on maintenance or avoid over-maintenance, and at the same time improve the quality of the scarf joint and the whole LVL product. In addition to this kind of low-level one measurement point follow-up, there are quite natural next steps. Here MillSIGHTS and Raute as one-stop shop for delivering mill-wide LVL solution is at its best. So let's expand the thinking from scarf saw. At scarfing, we know if the sheet is a face veneer or the inner layer of LVL, and therefore we can allow different sizes of holes in the scarf bevel. Since we know each stack ID from which we are feeding in the sheets to the line, we can also know the used grading parameters of those sheets earlier in the process. What this means in practice, you can see what type of knots can be allowed in the scarfing edge area without increasing the likelihood too high for those to tear the bevel in pieces at scarfing and get the whole sheet rejected. Yet when we continue from the stack ID at infeed, it's possible to track if the drying conditions were abnormal for that batch of production and if the overdrying could be the reason for the broken sheets instead of scarf saw adjustments. Sometimes you wish you could rewind back some events to truly understand the causes and effects. In LVL manufacturing, a lot is done in the hot press. When it comes to actual pressing, what we can do with MillSIGHTS is to go through each pressing if needed. Is everything okay with process parameters like thickness control and temperatures? We can also look back at the start of the process, what size of wood you got in, what grade distribution came out, and you can find out how you were able to transfer the strength and other properties to the end product. It's quite a mix of variables and machine parameters. In order to fully understand all this, a proper data collection from the process needs to be in place. In some areas, it's common that LVL producers buy the veneer outside from a separate veneer producer. For both parties, it's important to have certain transparency. Sharing some numbers from the process and analyzer certainly benefits both. For example, how much pressure there should be in the knife cap at lathe so that the sheet handling is easiest on the LVL production lines. Not to mention the drying conditions. When this is done with MillSIGHTS, the principle and the format of data is same for both parties and the cooperation can be taken to the next level. There's one more thing I'd like to highlight. That is Raute's analyzer systems offering, which is especially important on LVL strength grading. In order to achieve the needed strength for each product, you need a good set of analyzers. But when you combine the analyzer data with MillSIGHTS, it's a whole new world. From green veneer density deviation and the clipping strategies to grading tricks after drying for optimizing pressing times. It's possible to safely tighten the process safety margins so you can get the better and higher profit products from the same raw material. What we saw earlier, from the scarf saw Bevel, it's just a fraction what the latest Raute analyzers can do with the entire material flow. So yeah, the future for the LVL itself, as well as for the LVL in manufacturing, looks definitely bright. That's all this time. Thank you very much. Don't have a good day, have a great day.